Welcome everybody. Can you hear me all right? All right, so who here programs iOS? Okay. Who here programs Objective-C? A lot of them. Who is doing Swift these days? A lot of folks? Cool. All right. Who here has done some async stuff in iOS? A little bit. Who here thinks async is hard? Cool. All right. So the reason I put this presentation together is I did a talk a couple of years ago called Thread Safely. And I'd done a lot of asynchronous work like downloading stuff from the web, munging data together, putting it in core data, throwing it up on the screen and being able to correlate that with images that you've downloaded and all that kind of stuff. There was a lot of asynchronous work in those apps that I've worked on. And I made a lot of mistakes. And so that presentation was about all those typical types of mistakes that you make doing asynchronous programming. And so this talk is actually just to step back and walk through the basics. So anybody that's not familiar with asynchronous programming, we'll talk about justifications for why you want to do it. And then I'll go through some of the basic techniques that are available on iOS. And actually, it all works on Mac programming too. So everything we cover here today works on the Mac as well. So with that, let's get started. So I'm Joe Keeley. I'm from Denver, Colorado, and it's a pretty far journey here, but it's great to be here in Bangalore. I'm very excited. I've never been to India before, so it's a treat for me to be here, and I appreciate you listening to what I've got to say. As she mentioned, I work for MartianCraft. We do design, iOS, Android, and server-side stuff for lots of different companies. You know, I've done some venture-funded startups. I've done Fortune 100 companies. As our previous speaker was talking about enterprise apps, we work on those too, and those are really fun. I think there will be a lot more of those in the future. So async is very important for those because every single enterprise app needs to talk to a server, it needs to get data back, and it needs to put it back up on the screen. But as he mentioned, you want to have a nice user experience with that. And that's what we're going to talk about, is how you get that nice user experience using async programming. So I'm the co-author of this book, Mastering iOS Frameworks. This was back before Swift existed, so this is all Objective-C, but it's just sort of the next level of, once you've gone through the beginner stuff, then you can dig into all the little things that don't really deserve a full book, but they deserve a chapter. So we wrote a bunch of interesting stuff about like PhotoKit and mine's drawing a blank now, but a lot of other stuff in that book. And then last but not least, there's my Twitter. If you come up with questions that you don't remember today and you're thinking about stuff and you're like, hey, remember that Joe guy was talking about async, I'd like to ask him. Feel free to ask me, I'm happy to help you. All right, so why async? First off, let's take a look at what sync and async is. At a very, very basic level, synchronous task just means when I'm talking in my code and I say, please go do something, I'm going to wait until that something I call is done. So if I say, display something on the screen, change the size of my label, if I perform that synchronously, I'm going to wait until that completes before I move on to my next task. That's basically what synchronous means. Now, an asynchronous task means I'm going to call something and say, go do that task, but then I'm going to keep working while that task works, and then it can come tell me when I'm done, and then I can use the result later on. So that's just the basic difference between synchronous and asynchronous. All right. So long-running tasks can interfere with the user interface. Has anybody had this happen when you're building an app and you do something that takes a little bit too long and it messes up your app? Has anybody had that happen while they're working on stuff? Yep, a few of you. Yep. So what do I mean by long-running? Well, in a computer, 0.01666 seconds, that's 1/60th of a second, is a very long time. So anything that takes longer than that, and you're running it on the main queue, that's going to mess up your program. It's going to make it start to stutter. The user interface is not going to be responsive. You're going to have problems if you do anything on the main queue that takes longer than that. So that's what I mean by a long-running task. All right, so I've got an example here of just a really basic table view. So this is just some different examples of different approaches to async programming. And I'm going to show you an example of a program that I built that shows a table view. It's got a little bit of data in it already. And then we're going to go off and do some long-running tasks and display some more data in the table. Now, I just recorded a video of this so I wouldn't challenge the demo gods. So let's take a look at this. Now you can see that the user interface is performant. Now I can see this. I'm stuck. I'm trying to scroll and nothing is happening. The user interface is blocked. What's going on? Well, there my long-running task that got my additional data just finished, and now I've released the main queue and I can scroll again. So we can all agree that's bad, right? We don't want the user to be messing around on the app going, I can't scroll, it's not responding to me, is my phone broken? We don't want that to happen, right? So that's a bad user experience. We don't want that to happen. So the solution for this is to perform your long-running tasks asynchronously. But before we talk about the specifics of how we do that, let's take a look at some of the background for how we perform tasks asynchronously. What are the technological underpinnings of asynchronous technology? So first off, there's threads versus queues. Now, the way I like to look at it is a thread is a way of managing blocks of code, right? So this little gray box here, in my mind, represents the thread. And you can have all these blocks of code that perform on the thread. So that's a very, very simplified way of looking at it. So a thread is really just a construct for handling instructions serially. And on an iOS app, this actually, a thread is a POSIX thread, so it's the same as on a Unix machine, that is contained within the app process. So that's just part of your app that's running on the machine. Now the iOS will give your app resources, give it access to the number of threads that it can use, and that might change depending on what's going on the device, right? So that's something you need to take into consideration, is that a thread is just a resource like memory or anything else that or CPU power that your app needs to use. So you need to think about threads as a resource. Now, threads can be spawned and used with the NSThread class. Has anybody used that before? A few folks there? Okay. Now, anybody who's used threads directly, you might have learned that you have to manage them yourself, right? And you have to be careful about the system utilization, right? So if you spawn off too many threads, you can grind your app to a halt. I've done this before. And that can be very challenging to do effectively, especially with utilization on your app or your phone changing, right? So if you're switching between apps, stuff is happening in the background. You might get a memory notification. You can run out of threads when you're doing too much on your phone. So you got to be very, very careful with managing that. So personally, I recommend using GCD or Grand Central Dispatch instead of using the NSThread directly. All right, so that's what threads are. Now let's talk about queues. So the way I like to think about queues is a queue is this nice light gray background, and there's a thread, and then maybe another thread, and there might be more threads, or it might only be one thread, and then there's blocks of code, right? So a queue is actually a Grand Central Dispatch construct, and it's just a way of managing code execution on threads. And you'll notice I've got the S in parentheses there, so it might only use one thread. If you do a serial queue, you might only have one block of code happening at a time. And this is a great way to sort of control access to your resources, or to control access to what's happening at one time. Now a queue can manage one or more threads depending on the type. As I just mentioned, there's a serial queue, which will do one thing at a time, and it'll enforce one thing happens at a time. There's also a concurrent queue, which means you could do lots of stuff all at the same time. So Grand Central Dispatch has got years of Apple's tech experience built into it. I don't remember exactly when it started, but it's been back, and it started in the OS 10 days, and I want to say it was 10.4, but I'm not entirely certain about that. But it's been around for a long time. Grand Central Dispatch manages queues and threads very, very efficiently based on the system load. So it's very smart about how it manages the threads and how it manages the code happening on those threads. So it can actually dynamically size up and size down your queue and how many threads are taking place and how many things are happening at the given time based on what's going on your device. And it's sensitive to preventing performance problems from happening. So using Grand Central Dispatch is a great way to sort of insulate yourself from the vagaries of threads and have Apple's smarts do the work for you. All right, so now that we've talked about the difference between threads and queues, let's talk about how we actually use queues. Before we dig into that, we need to talk about the special queue that all apps have, and that's called the main queue. So sometimes you might hear the main queue and the main thread used interchangeably. They're not the same thing, right? So what we just talked about are the threads and the queues. The main queue is a Grand Central Dispatch queue, and it manages the main thread. So you got to be a little bit careful in certain circumstances if you're dealing with the main thread directly and ignoring the main queue. Bad stuff can happen. So generally I recommend if you're going to talk to the main queue, talk to the main queue. Don't talk to the main thread, okay? All right. So the main queue manages the main thread, as I just mentioned. And the important thing to keep note there is that the main queue is what runs your user interface, right? So all the UIKit stuff that you do, view controllers, views, labels, buttons, all your touch interaction, all that stuff happens on the main queue. So you really want to be careful with what you're doing on the main queue. So any custom code that you've got in your view controllers, all that executes on the main queue by default. So anytime that you fire up a view did load, or you perform something in there, or you do a custom method inside that gets called and view did appear, all that is executing on the main queue by default. And so if that takes a long time, and if you remember what our long running task is, 0.0166 seconds, that's not a lot of time. So you want to be careful what you're doing with all those different instructions, or else they'll make your user interface start to stutter. All right, so now that we've talked about all this, how do we actually get off the main queue? Well, there's three different approaches that we're going to talk about today. The first one is just NSOperationQueues. There's some methods that are available to do that. And then we're going to talk about Grand Central Dispatch, and then we're going to talk about NSOperations. So there's three different ways you can get off the main queue. All right, so the first one is actually the simplest and the quickest. And if you just need to do one little thing off in the background, this can be a good way to do it. All right, so there's these NSObject methods that are available, for example, to perform selector in the background. So if you guys are familiar with Objective-C, all you need to do is have a method, and then it can take one parameter. And that has to be an NSObject type parameter. It has to work with ID. Then you can also use perform selector on the main thread to get back. So these are some of the methods that you can use to get off. Now let's take a look at our example and see what happens when we run this in the background. So if you remember, we've got this table, and we're going to tap the perform background thing, and it's going to show a table with some data in it, and then it's going to go off and do some long running stuff, and then it's going to put that stuff back on the table. Now let's watch and see if it's responsive. All right. So now you notice I'm still scrolling the table. That long running stuff just took place and all this stuff appeared. And the user interface was responsive the entire time. So that's the goal. That's what we want to be able to do by performing things asynchronously. And of course, this is a simple and contrived example, but it gets the point across that you want to keep your user interface responsive to the user at all times. Okay, so let's take a look at the code that makes this happen. So in Objective-C, the first thing you need to do is have a selector. And just for convenience, I did it this way. So I declare the selector, and that's the name of my method that I want to run. And I've got this long-running task, and I'm going to run that long-running task 5 times, just so I get a lot of data, and you can kind of see an example of how you might do this. So for each iteration, I'm going to create a number that I'm going to pass to my selector, and I'm going to pass that iteration number. And then I'm just generating labels that say which iteration I'm in and which number I've got. So that's the basic approach for the NSObject approach, is I call perform selector in background with object, passing my selector, passing my iteration, and then that will actually spawn off and do the work in the background. When I'm done, I need to get back to the main thread to go update my user interface. So I call perform selector on main thread, and I pass it the select that I want, and that's just updating my table data. And I pass the object that I want, and I tell it that I don't want to wait until I'm done, right? So I don't want to block and be a synchronous call. I want that to be asynchronous. Now the same thing to do is quite easy in Swift. So I can define a selector, and that's just my method. I'll do an iteration as well. And then the key here is I'm creating an NS number for my integer, just so that I'm passing something that Objective-C knows what it is, right? And then I just call perform selector in background. And I forgot to mention, but self is my view controller at this point. So any NS object has access to this. So you can use it from your view controller. You can just create an object if you need to make these calls. All right. And then in Swift, to get back to the main queue to update my user interface, I just use this same method. So perform selector on main thread, passing my data, and I tell it I don't want to wait. So that's the NS object approach. Now, the one thing I didn't mention here is this approach uses threads. It does not use Grand Central Dispatch. And I just said I recommend not using threads directly. So this is something you can use if you've just got one or two or a handful of very simple things that you want to do in the background. And as you saw in my example there, it was a pretty simple task. So it'll work just fine for this. But if you're going to do a lot of work and you might end up spawning a lot of threads, you probably don't want to go with this approach. You'll want to look at Grand Central Dispatch or NS operations. So let's take a look at that. All right, so let's take a look at Grand Central Dispatch. Now, GCD is Apple's way of managing multiple operations at once. So this is sort of a general thing that handles both like low-level system stuff like threads and sockets and file descriptors. There's a lot of interesting stuff in there. So it's got queues, it's got sources, it's got groups, and it's got semaphores to do locking. So I highly recommend if you guys, if you're interested in this, spend some time with the documentation, spend some time looking up and reading, and spend some time just experimenting with it and see how it works. So now let's talk about the specifics of how you actually put code on a queue and make it run in the background. The first thing that you need to do is get a reference to the queue. And so we had talked about what the queue was, right? And that's just the construct that manages all the threads. Now there are two different types of queues. So there's the custom queues that you can create, or there are system provided queues that you can use. And in this example, we're going to use a system provided queue. So in Objective-C, the first thing I'm going to do is grab a reference to the system provided queue. So the reference is going to end up being a dispatch QT. And I'm going to call that a work queue for whatever. And so I call this function called dispatch get global queue. And then there are a few different types of global queues that I can use. And they've all got constants that you can use to identify them. So there's a background, a low, a high, and a default. I'm trying to remember what else there is. But you can look at those. When you do type ahead, it'll actually show up and you can pick which one you want. And then that last parameter there is just always 0 at this point. It's for future use. So that will give you a reference to the queue. So now you can call stuff on it. In Swift, you do exactly the same thing. So you just define a variable or a constant, and you call the function the same way. All right, so now that you've got a reference to the queue, you can start adding work to the queue. Now there's a function that you need to call called dispatch async. And so this is how it looks. In an Objective-C, you're going to dispatch async with one parameter, which is the queue, and the second parameter is a block. And so you can pass it a block of code and do anything you want in there. In this case, I'm just calling my selector. So it's very similar to what I was doing in my previous example. But this is just a kind of a simple way to do it. So you can keep it as simple as this, or you can do additional work in the block. As Scott was saying this morning, it's good to keep it simple. This will help with your debugging. So I'm just going to pass this, this call with my iteration number, and that'll go make my, do my work. In Swift, it's very similar. It looks just the same. So this is Swift 2.2. You'll notice I just call it like this. I pass my method call, and there it goes, or my function call, and there it is. Swift 3. In Swift 3.0, there's new syntax to do this that I'll talk about in just a bit. All right, so now that we've gone and done our work, we need to get back to the main queue to update our UI. Here's how we do that. All right. So now we'll call dispatch async, and we're going to point to the main queue. There's a function here that will get the main queue for us and return a reference to that dispatch QT that is the main queue. And then you can pass that a block of work as well. So then I'll just call my method to go update my UI with the data that I just produced. And in Swift, luckily that's not too hard of a translation. You just call the function to dispatch async, specify the main queue, and I can call my function there with my data. So here's a couple of points about Grand Central Dispatch that I want to highlight. So as I mentioned, Swift 3.0 has really nice new support for the language using dispatch. And so it's actually got a keyword called dispatch. So you can do dispatch.sync, a block of work, dispatch.async, a block of work. And it's even got a thing called work items. It's very similar to a closure or a block. And you can create these work items and then add them to the dispatch queues. So I definitely encourage you to look into that as well. I mentioned before, you can also create your own custom queues. So if you don't want to use the system provided queues and you want to have your own queue to sort of isolate your work and keep it safe from all the other stuff that's going on, you can create your own queues. And like I said, there's two different types. You can create a serial queue, which does one thing at a time, or you can do a concurrent queue, which can do lots of different work at the same time. GCD also has some additional functions to deal with system resources, and GCD's got a way to do concurrent stuff on a collection. This is one of my favorite things of GCD, is if you've got an array and you need to do something to everything on there, like in Swift you can use a map, right, or a flat map to sort of touch everything on there. But if you use GCD dispatch apply, you can perform concurrently operations on everything in your array, and it happens really, really fast. So it's basically like taking a block of work and applying it to your collection. It does that work very, very quickly. So if you ever need something like that, dispatch apply can be very, very useful and very, very quick. There's a lot more to describe about GCD, so I'm not giving it full justice here, but I definitely encourage you to investigate it more. All right, so that's Grand Central Dispatch. Next up, let's talk about NSOperationQueue. So the first thing you need to do, and you only need to do this once, is have an NSOperationQueue to do the work for you. So this is very much like getting the reference to the GCD queue that you want. In Objective-C, you can have an instance variable, and you can just create an operation queue using alloc and init. There are a few things that you can configure on a queue. Typically, I recommend not doing that unless there's a very specific thing that you need. One of the things that you can configure on an NSOperationQueue is called the max operations. And by default, that's sort of a large number that's not defined, as the documentation says. But if you want to do if you want to make an NSOperationQueue serial, you can set the max operations to 1, and then your NSOperationQueue will function just like a serial GCD queue. If you want to sort of limit things based on what you know is going to be limited resources, right? For example, if you're downloading a bunch of images and you're using operations to manage your downloads, and you're in low network conditions, you might set your max to 2 or 3 so that you prevent overloading the network calls. And in Swift, this is just as easy. You can create a constant or a variable to handle your operation queue, and you just instantiate it. So once you've got an NSOperationQueue, you need to add an NS operation to the queue. Now there's 3 different types of NS operations. There's an invocation operation, there's a block operation, and then you can always create subclasses of NS operation and sort of compartmentalize all the work that you want to do in a subclass. For this example in Objective-C, I'm going to use an invocation operation just to show you how it works. So here I'm going to need a reference to a selector. So again, this is the selector that I'm using to do all the work, right? The long-running task. I'm going to call it 5 times. So I'm creating an NS number with that so that I can pass it to my selector. And the NS invocation operation, I need to allocate that and then init with the target. And then I pass it a selector, and then I pass it an object. This next line is sort of important as well. NSOperations have what's called a quality of service parameter. And this quality of service parameter tells iOS how important this is to the user. So in this case, I'm just doing background work. The user didn't, do something expecting to get a result right away. So this, I'm just kicking it off. It's going to run in the background. Whenever it's ready, I'll display it. So in that case, I gave it the quality of service background. If the user had, say, tapped on something to go see a larger version of an image, I might say that that was user initiated. So I want to respond to it right away. I want that to be the top priority. So you can provide a quality of service user initiated to tell the operating system this is the most important thing you're doing right now. And last but not least, you can set up a completion block. So when this operation is done, when things have happened, you can give it a block for something to clean up or do anything like that. And in this case, I've just got a log so I can see what's happening in my console. And then you can just add the operation to the queue. And so once the operation is added to the queue will say, hey, am I free? And it'll start kicking off and doing the work for you. In Swift, I'm using the other variation of an operation, so the block operation here. And that's one's very, very simple. You just declare the block operation, and you pass it a block, so a closure, just a piece of code. And you can put anything in there you want. Like we mentioned before, simple is better. So here I'm just calling my method with that iteration. And then I'll set my quality of service, and then I'll add it to the operation queue. And that'll kick off the work. All right, so now that I'm going and doing my background work, I'm going to go back to the main queue to update the UI. So how do I do that? NSOperationQueue has a class method that's very handy to be able to get the main queue. You can use this in other cases too. So the example where I said dispatch async, go get the main queue in GCD, you could also do it this way. You end up in the same place. But this is just kind of a nice, convenient method of getting to the main queue. So here I'll grab a reference to the main queue, which is also an operation queue. And then I'll add a block operation here that's going to update my UI. So that'll perform on the main queue. And then I'll just add that operation to the main queue operation queue. In Swift, I can do it exactly the same way. I'll use that class method or class function to get my main queue. I'll add the operation, and I forgot the code there to add it to the operation queue, so that wouldn't run. All right, so that was just kind of a quick overview of NSOperationQueue. As I mentioned, there's the invocation operation, the block operation, and then I didn't show an example of this, but it's definitely something worth investigating. You can create custom subclasses of your NSOperations. So if you're doing a fairly complex task that's long running, using a custom subclass of NSOperation is a great way to do that. You can compartmentalize all the logic that you need in that subclass and keep it all together and easy to deal with. Some stuff that distinguishes NSOperationQueue from GCD is the fact that NSOperationQueues and NSOperations support cancellation. You could build that in yourself in GCD, but you'd have to add it and figure it out all by yourself. This logic is built into NSOperations. So you can just say NSOperation, if you've got a reference to it, cancel. And then you put in some code inside your operation and say, well, if I'm canceled, don't do the hard work, just skip right out to the end, right? NSOperationQueues and NSOperations also support dependencies. That's all built in. In Grand Central Dispatch, you've got to use something called dispatch groups, and the syntax is a little more difficult. But in NSOperations, it's very, very simple and straightforward. So you can support dependent operations. For example, I could create operations for 3 API calls, and then when I'm done, I can have another operation to go update the UI or consolidate my data and then do some updates. And then that could be dependent on the completion of all 3 of those. Now, the interesting thing about that is it's not dependent on running on the same queue. So you could have multiple operation queues. For example, I could download my API data from one queue, I could download my image from another queue, and I could perform even more, putting data together, updating it in core data in yet another queue. And then when those dependencies are all resolved, I can perform my final completion. So that's a very, very useful tool to know about and be able to use when you're performing asynchronous tasks. NSOperationQueues can suspend and resume a queue. So let's say you're using network operations and you've created a network operation, you've got a whole bunch of them in this queue, and you've lost your network connection. What do you do? With an NSOperationQueue, it's very, very simple. You just tell the queue to suspend, and it'll stop. And when the network comes back up, you can say, resume, and it'll pick back where it left off and continue running your operations. If you implemented something like that in GCD, you'd basically lose all those blocks, or they'd just keep running, unless you built in a bunch of custom code yourself. So that's a very convenient and nice tool to have when you need to be able to shut things off and turn them back on again based on your network conditions or your system conditions or your user conditions. And last but not least, be sure to use the NS quality of service to tell iOS how to prioritize these operations, right? So as I mentioned, you can tell it this is a background operation, or this is something that the user initiated or the user is expecting to have quickly. And that'll help iOS prioritize things for you, so you don't have to do the work to do that. All right, so now that we've covered a lot of these different topics, so these 3 different approaches we've talked about, the NS object approach, we've talked about GCD, we've talked about NSOperationQueues. Let's talk about a specific one that should be near and dear to everyone's heart here, networking. So who here has used NSURL sessions and NSURL session tasks? A few folks, cool. Who here uses like a third-party library for networking? Cool, okay. For me at least, in my experience, I've kind of gone away from the third-party libraries. And I've been able to do pretty much everything I want in NSURL session, URL session tasks. Actually, for one project, wrote a wrapper around it, so I was talking about NSOperationQueue networking. I just built a really, really simple wrapper around NSURL session tasks so I can make them operations, and I can throw them on a queue, I can cancel them, I can suspend them, and do all that kind of stuff. But here let's talk about just a really the straightforward approach to making a network call and what happens asynchronously. So in Objective-C, for me to create a network call using an NSURL session, I need a URL, and I can also do this with a URL request. If you need to do something like authorization tokens or something like that in your headers, you can use a URL request or a mutable URL request. I need a reference to the session. So in this case, I'm just using the shared session as an example. And then I need to create a session task. So I can create that task using the URL or a URL request. And then I need to pass it a completion handler. And that completion handler is going to get my data, my response, and potentially an error. Now in Swift, this looks very similar. I like to use guard statements. Anybody use guard statements? A few folks? Yeah. So in this case, I'm trying to get my URL from a text field, for example. So I make sure I've got it, and I make sure it actually translates into a URL and it's not gobbledygook, right? If it is, I just kick out. You probably want to handle that more gracefully. So I get a reference to my session, and then I create my session task, and I pass it my URL. So the key thing to note here is when that runs, and it goes off and does the network request, and it comes back, your completion handler is executed on a background queue. Okay? So this is a queue that's managed by NSURL session. So if you're going to do some heavy lifting with your response, that's the place to do it. And in this example, everybody serializes or deserializes JSON, right, for their response, or maybe XML, whatever. This is a good place to do it. So I'm in my completion handler. So I'm just going to deserialize my JSON there. And then if I don't have an error, I'll be able to continue on. And so I'm going to do the exact same thing in Swift. I'll make sure I don't have an error. I'll make sure I've really got data and it's not 0 or null. and then I'll just deserialize that, and if I get an error, I'll be able to kick out. And that's all happening in the background, right? So all that heavy lifting is going to happen in the background, and I'm not touching the user interface. So once I've done that, now I'm able to go back to the main queue and update the user interface with results. So here, and this is going to go back to your preference, right? Whether you want to use GCD to get back to the main queue, whether you want to use your NSOperationQueue to reference the main queue. But now you can go back to the main queue, and here I'm just grabbing the response, putting the status in a string so I can see it on the app, and then I'm putting the JSON in a text field so that I can view it, right? You'd probably do something smarter or more interesting with that. But here's where you can do your UI updates, right? So you want to make sure you're on the main queue when you're doing your UI updates. All right, and in Swift 2.2, this is going to look very similar. I'll dispatch async to the main queue. I'll see if I've got a response, update my UI, and I'll take my JSON and I'll put that on the screen so I can look at it. So that's just sort of the basic approach for doing networking, doing your hard work offline in the background, and then updating the UI when you're done. All right, so now that we've talked about a lot of different asynchronous stuff, let's talk about some stuff to avoid. I've made many mistakes doing this in the years. And I've screwed it up possibly every way that I can think of. So hopefully, I can share some of these problems with you and you can avoid them. All right. The first one, let's just talk about some general async risks. So anytime you're doing asynchronous software, there are some things that can happen. The first one is simultaneous updates. So let's say you've got two threads going on, and they're both updating the same piece of data, right? Now, if you don't have any control over that, bad things can happen. For example, let's say you're counting some objects in this thread, you're counting some objects in this thread, and you want one counter to show up on the screen. If they're both updating that, your count's going to get off every time, I promise. So some ways you can deal with that, you can adjust your pattern to perform that count serially, right? Put it in a serial queue. That'll control access. You can use a locking mechanism. There's a couple of different ways to do that. Or there's some functions called OS atomic functions. So if you're using scalar values like an integer or something like that, you can use these OS atomic functions that do locking at the kernel level, and you can get a very, very quick response out of that and still have your locking mechanism. So if you just need something simple like a counter or something that'll go in a scalar value, investigate those OS atomic functions. All right, the next general problem that you can run into are race conditions or out of sequence conditions, right? So this happens when you kicked off a bunch of stuff on this thread, some stuff on this thread, some stuff on this thread, and you sort of assume that when all these things are done, I'll be able to do my update, right? And show stuff on the UI. Well, when you test it locally, it works, everything's great. When you hand it to a user, it's totally screwed up, right? You don't get the answer you're looking for. So frequently what happens is in different user conditions or different system conditions, those threads are going to take different amounts of time to take place, right? Or operations on different threads and different queues are going to take different amounts of time. So that'll end up having stuff happen out of order or in different orders than you expect. And frequently, it will find a way to trip up your logic. So some ways that you can do that, or the ways that you can deal with race conditions, are using serial queues to sort of force your order. That'll make things take a little bit longer, but that way you can always ensure that things happen in the sequence that you want them to. So the first thing is understanding that you need the sequence to happen. And the second thing is enforcing the sequence. So a serial queue is one option. Another option that you can use are to use dependencies. As I mentioned with GCD and NSOperations, in GCD you can use dispatch group to sort of group things together and figure out what your dependencies are. And in NSOperations you can use dependencies to say this operation shouldn't run until these three operations have completed. So that way it'll force those things to work every time, and you'll still get the benefit of concurrent programming. So those are some ways you can deal with race conditions. Another general problem are deadlocks. So this is the case where you've got two different threads, and this thread is saying, I'm going to wait until this thread is done with something, and this thread is saying, I'm going to wait until that thread is done with something, and now they're stuck, right? They can't get out. So the way you deal with that is really you gotta think about what's happening there. So you really need to reduce your logical dependencies. So why is this thread actually dependent on this thread doing something, and vice versa, right? So give some thought to why those dependencies exist and refactor them. Take them out of the equation. Another thing you can also do is use async whenever possible. So if you can avoid being in the condition of having to say this thread needs to wait until this thread is done, make it asynchronous and make a dependency instead, right? That's another way to deal with it. So that's deadlocks. This is my favorite one, is updating the UI from a background thread. Who's done this? You know how fun that one is, right? Cool. So what happens there is if you update the UI from a background thread, if you're running on a single core device, it works great. No problem, most of the time. If you're running on a multi-core device, it'll work sometimes, and other times it won't. And for me, it always happens, I test on the slowest device I've got, right? So I've got my single core device, testing, everything looks great, send it to the client, he's like, it's not updating the screen, what's wrong? I'm like, updates every time for me, I can't reproduce it. So that's where you gotta understand what the client is using, right? Or what the target is. Take a look at their device. If it's multi-core, what's probably happening is you're updating on a background thread, and it's just getting to it when it feels like it, right? So it waits a few seconds, and the UI might update. So how do you deal with that? Well, there's a couple of different ways to do it. The first one is really just sort of code review, right? So if you identify this situation, you've dealt with it in the past, you'll be able to look through your code and be like, ooh, that's a spot where I might be doing it. Your network completion handlers are a really good one. I see that all the time, right? Where you've got this completion handler, self.tableview reload data. Nope, not going to work. You need to dispatch async back to the main queue. And we'll talk about a couple other examples in just a minute of places where you can fall into this hole frequently. In Objective-C, there's a way that you can find this. If you've got something that's really, really difficult, you're just not able to find it with your code review or with the typical sort of situations that you know to look for. If you're using an Objective-C project, you can method swizzle set needs layout, set needs display and rect, and you can have it stop or log where you are when you're off the main queue updating one of those methods or calling one of those methods. So what you're looking for when you're updating the UI, if you're debugging and you're like, I think this is where it's happening, this is where I'm seeing the problem, what you want to look for in your debugger when you're doing your UI update, so here's my update table, right? Table.reload. Make sure the queue is com.apple.main thread, right? If it's not in there, you're probably updating on a background thread and you've got a problem. All right, next up. This is one of my favorites. And this has happened to me a bunch. Unexpected queue from block-based SDK methods. So as of iOS 4, when Objective-C 2.0 came out, Objective-C 2.0 introduced the concept of blocks, right? So the ability to have these little blocks of code. And Apple started doing a lot of stuff in the SDK to be able to do things sort of asynchronously or, completion handlers, perform this task with block. They started adding that to the API quite a bit. And in some cases, the documentation is really good and says, oh yeah, this is definitely happening on a background thread. In other cases, the documentation just doesn't address threads, right? So it might be happening on the background, it might not. You don't know. So this is a case where you can end up updating the UI on the background thread and not even be aware that you're doing it. So in the iOS SDK, there's some things you should look out for. The first one's like completion handlers. Anytime you see the word completion handler, you want to take an extra look at that and make sure it's not getting performed asynchronously. It probably is. Error handlers. So anytime you see something in the iOS SDK that says, with error handler, there's a good chance that might be performed on the background thread. So definitely investigate. And then any method parameter that you titled with block is going to get performed on another thread probably. I can't say that with 100% certainty because I don't know all the source code, but it's definitely worth looking into. So these are all cases where you might end up on a thread that's not the main, or on a queue that's not the main queue and not be aware of it. So definitely look out for that. Over dispatching. This is kind of one that I see a lot in code. And it's not necessarily a bad thing, like it's not going to cause a problem immediately. It just makes things confusing. So look at this example. So I'm getting a queue to do some background stuff. And I'm dispatching async to this background queue. And my block here is doing some core data work. So I've got to manage object contacts, and I'm going to perform block and do some work. Well, what's happening there? So what's actually happening is all I've done is dispatch the call to this in the background. So all I'm doing is making one single call in the background to go do some other asynchronous work on yet another queue. So I'm not saving myself any work. I'm not doing anything more efficiently. All I'm doing is making things confusing. So by doing this dispatch, I'm just sort of moving where I make my call to this asynchronous method, right? So that's something you just want to look out for and avoid in your code, is over dispatching, because that can make your call stack really confusing. If you do it too much, you can get performance problems. But most of the time, it just makes stuff confusing and doesn't give you the benefit that you think you're getting. Last but not least, retain cycles. I was working on this slide after being on the plane for 20 hours, and so I'm not going to be able to explain it well. But the basic thing that can happen is when a caller retains a block, and this always happens, right? So when you define a block in your code, your caller is going to have a strong reference to it, so we don't lose the block, right? Now, inside the block, you might have a reference back to self, to update a variable or something like that. And if that has a strong reference, the two might have strong references to each other and never go away. So that's what a retain cycle is, conceptually. There are different semantics for how to deal with this in Objective-C, Swift 2.2, and Swift 3.0. Semantics change between 2.2 and 3.0. In closures, in 2.2, they're escaping by default in Swift 2.2, and they're non-escaping by default in Swift 3.0. So you just need to deal with it slightly differently. And then in Objective-C, you typically do the weak self dance, and you'll notice none of my examples had that. Nobody yelled at me for that. But you typically want to have a weak reference to yourself to avoid getting your retain cycle in Objective-C. So again, the gist here is just avoid having your strong references back to the caller, if you can, in your block, unless they're absolutely necessary and you actually need them for the block to work properly. And then give some thought to, if you have that situation, how you're going to be able to resolve that reference and make it go away so that your memory gets dismissed. And I've gotten my note. It was too jet lagged to explain that super clearly. I saw some nodding heads, so hopefully that was pretty good. All right. So that's what I've got today on asynchronous. Does anybody have any questions on this kind of stuff that I could address now? Yeah, go ahead.
What is the relationship between session tasks? When you provide a block to a session task, the session task itself, it is executed in a different queue, in the main queue, the same queue as?
It has a private queue. So the session manages a private queue. And there's a couple of different things specifically about that. If it's a data task, it's got its own private queue, and that's inside your process, right? If it's a download task, you can configure that to run out of process, right? So it's possible to set up your downloads so that that'll run completely out of process. If your app crashes while that download happens, it keeps going. And then it'll tell your app, I'm done, right? So it's managing in two different ways. It can be either internal, inside the process, or external. Yep. Any other questions? Yeah?
Do you suggest we use a framework like Bolts to manage async tasks? Or we use these?
I personally recommend doing something like this directly. Because the third-party framework can sort of add another level of indirection, right, or abstraction. And if you understand what's happening in the third-party library, and you're very comfortable with what's going on there, feel free to use it. But if you're not comfortable with what it's doing, then you can get yourself in trouble and not understand why, right? So I would definitely encourage you to spend time with this, either with GCD, NSOperations, whichever approach you're going to use. Get good at those things first, and then investigate the third-party library so that you're comfortable with what it's doing, and you're able to debug it if you run into problems. So, yeah?
The NS notifications are not necessarily serialized, right?
Correct.
So if you're doing some stuff in background background queue,
Yes.
and in completion block you call, okay, notify my view controller to do stuff.
Yes.
There are chances to go things wrong. So
Ab-
how do we handle it?
Absolutely. So the question was, NS notifications aren't necessarily serialized. They may come from background queues, right? So for example, if you get something in a completion block and you fire off a notification, guess what? You're in the background queue. So what I would typically recommend is A, don't use notifications for that. So refactor to do it a different way. Or if notification is the best solution, and there are a lot of cases where, yeah, it is the best way to do it. In that case, be explicit in your notification handling method when you receive the notification, which queue, and always dispatch to where you want. So always dispatch either back to main queue, or if you're doing stuff in the background in response to the notification, do it that way. So there's two different ways to look at it. Yeah.
And the normal notifications which we fire
Yeah.
are also not in sync, right?
Correct.
So, there are chances when we notify a certain piece of code from different
Yes.
classes. So is there any way to, I mean, again, we will call it in main queue, but
Yeah.
is there any way to not do that? Or
Yes, absolutely, and that's why I say my first reaction is don't use NS notifications because you can get in exactly that pickle, right, where you get stuff happening, and the worst is, like, for example, let's say, and I ran into this on a recent project. We had notifications built in, right, to say, okay, my API is done, reload the table, right? Well, we were making multiple calls because we're doing paging, right? And let's say the first call takes longer than the second call, and I get them both at the same time. Well, now my table's crashing because I'm trying to update twice in the same UI animation block, right? So it's just, the table says, I don't know what to do, just, I can't handle it. So one way you can do it is sort of take away the notifications and come up with a different approach. Use a serial queue to handle those things. And so I sort of built my own serial queue to be able to handle, a whole bunch of paging notifications. And so I would just pull one thing off the queue and say, all right, I've gotten an update. Now I'm going to update the table. And then I don't do anything until the animation is complete. And then I pull it again, right? So you can do stuff that way where you build your own structures to prevent those sort of notification collisions that you're getting. And those are very difficult to debug, aren't they? Yeah. So all I can say is when you get in that situation of having the notifications that are crashing, take a step back, look at what's really happening, what you're trying to accomplish, and potentially refactor. So I mean, it's definitely worth, step away and just have a cup of coffee, think about it very carefully, because otherwise you'll make quick fixes, right? Which is, I'll just, I'll do another dispatch async to the main queue, right? And the same thing keeps happening. So yeah, try that. Other questions?
You mentioned in one of your projects you have worked to bind up your networking call using NS URL session
Yeah.
in the NS operation or NS operation queue.
Yeah.
Can you explore more how you have done that? Because I'm assuming if you're configuring your NS operation queue to be run in background,
Yeah.
and again NS URL session to be in async operation, so actually it is coming async operation inside another async. So can you explore more, actually, a little bit how actually?
Yeah, I might have to talk to you afterwards about how I did it, because right now I'm like trying to remember. I had to do something a little bit tricky with like a run loop to make it work, right inside there. But the gist was I just sort of wrapped the NSURL session task inside a custom NS operation, and then I have like the start method kicking off the resume, right? And then when it responds or when it comes back, then I've got it completing the task, right? Or completing the operation. And then I had to do a little bit of magic in there to make it all just sort of function the way that I wanted to and have it support cancellation properly, right? But yeah, if you like to talk about it more, I can actually show you the source. Cool. Yeah.
How do you test GCD async tasks?
That's a good question. Are you talking about a unit test or just generally?
Unit test.
Unit test?
Although you can dependency inject NS operation and you can wrap
Yeah.
it around and you can unit test, but it's hard to test a GCD.
It's very difficult to test. So what I would say is, if you can refactor so instead of having the logic directly inside that block, factor it into a method that you can unit test, and then you still have the issue of the asynchronous nature, right? But at least you can confirm that your logic works, right? So that's one thing that you can do. I have tried doing some stuff async in unit test, and you can kind of twist things around to make it work, but it's fragile. So it doesn't really tell you much, unfortunately. So yeah, that's the best I've got on that. Other questions? Okay. I've got 3 minutes left. That worked out very well. Hold on a second here. All right. If you'd like to learn more, we do training, mentoring, code reviews, that sort of thing. And of course, I'm always happy just to answer questions like on Twitter or just in the halls or whatever. So track me down, and I'm happy to chat about stuff. So again, thank you very much for your hospitality, and it's wonderful to be here in Bangalore. Thank you, everyone.